Let's see, the foci are -2, 8 and 2, -2, 0.
Wait, where'd you get that from?
I'm looking at the bottom question. And the vertices are -2, 9 and -2, -1. Okay. So this is an example of, given sufficient conditions, state the type of conic and how do you know, and it asks us to write the equation. Okay, so we're not going to have to graph. It turns out it's actually really helpful to do a rough sketch of the graph though. So I'm a very visual person. The first thing that I would do with this is make a rough sketch. Okay, because from this information, you know where the foci are, you know where the vertices are, you're going to be able to find the center, and then we're going to find A and B and C, where are the co-vertices, what type of conic is this. So make a rough sketch. Here in 8, 1, 2, 3, 4, 5, 6, 7, 8. And -2 and 0. Good, so these are the focal points. And for our vertices, we have -2, 9, and vertices and vertices. Okay. Sufficient conditions. Is this an ellipse or a hyperbola? And why?
It's a hyperbola because it's out of the box.
It's a hyperbola because what's outside the
Oh, no,
box?
it's not. Never mind. Or, no, yeah, no.
No, yeah, no.
Wrong.
You're on the right track, okay?
No,
and
it's
another.
not a hyperbola because it's in the box.
All right.
Yeah.
So there's an expression, a cliche that will help you remember how to determine if it's an ellipse or a hyperbola, and that is think outside the box. It is the hyperbola for which we draw a rectangle, and so the focal points are outside the box for the one with the box. Think outside the box. That might even be on those notes. Anyway, so because the focal points are inside the vertices, Jasmine knows this is not going to be a hyperbola, so we can assume it's going to be an ellipse. Great. Our next step is to figure out where the center is. This is up at 8, this is 0, so right in between would be 1, 2, 3, 4. Here is our center. Okay. And for the ellipse, so we know now it is an ellipse. We have to talk about A and B and C. The little variables, what do they represent? They're going to be a distance from the center to the something. So Haley, for the ellipse,
Well, A is like to the vertices.
great. So A is distance to the vertices, which in this example is what?
A squared. Oh, I was going to do the formula.
We're going to find B. We don't know where the co-vertices are. We're going to find that, but first let's figure out what A and C are. So what's A?
5.
5. Great. And C is the distance to the focal points.
Why is it 5?
1, 2, 3, 4, 5.
Okay.
1, 2, 3, 4, 5. Distance to the focal points from the center, 1, 2, 3, 4. And so, for the ellipse, the focal points are inside. What do we do?
You use the formula. Don't use the
Yes, but which one? Because for ellipse and hyperbola,
A squared equals C squared plus B squared.
let's see, A squared equals C squared plus B squared.
Our teacher does ellipse and cyperbola.
A ellipse and hyperbola.
So that would be C squared.
I like that. Although A ellipse and hyperbola. Okay, I like that. The way that that I think about this is, we know that for the ellipse, because the focal points are inside, C has to be less than A. So if C squared were equal to A squared plus B squared, C would be more. Okay, so solving here, we get 5 squared equals 4 squared plus B squared. And so B equals 25 minus 16, and it's a 3.
Where does the 4 squared come from?
C, distance to the focal points is 4, so that goes in here, for C. And we're going to solve for B. Did I make a mistake?
No, I have a question.
All right.
Is it always going to be plus? Let's say it was a hyperbola or...
Yeah, so good question. Over here, we'll compare and contrast. For the hyperbola, for the hyperbola,
So,
yeah, we're going to have C squared equals A squared plus
it's always
B
plus.
squared. Right.
Sure.
Okay. All right, what are we doing here? We could graph at this point, but I think it's just asking us for the equation. Okay, so we know that 1, 2, 3 co-vertices would go out here, and 1, 2, 3 co-vertices would go out here. I'm trying to come up with the equation. So you have in mind the general form of what the equation of the ellipse would look like? I'm going to erase the question. General form, so ellipse, we're going to have plus, we're going to have equals 1, we're going to have something squared, and we're going to have something squared. Okay. The rest, we also know this, we're going to have an x and we're going to have a y. The rest is up to us. What goes where and why? All right, let me ask more specifically.
Oh,
What information would you get from here, the stuff inside the parentheses? Haley?
that's how you find the vertices, right?
Well, if it's a
Oh,
parabola,
yeah, it's a
that,
parabola.
because the vertex of the parabola is kind of like the center. The stuff from inside parentheses is what gives us information about the center. Okay? Center. And our center for this ellipse is -2, 1, 2, 3, 4. Okay, so the center is -2, 4. That information is going to go in here. So we're going to have x plus 2. And we're going to have y
minus 4.
-4. Y -4. Great. All right, now here's the, if that wasn't confusing enough, here's what gets really confusing, is which goes under which. Okay? Because for the ellipse, the vertices, we call the vertices the longer axis always. Whereas for the hyperbola, the vertices are the ones that are under the positive term. So, our longer axis is here. So the vertices go in the y direction. So a squared is going to go under the y stuff. Co-vertices go in the x direction, so b squared is going to go under the x stuff. So in the y direction is where we get the vertices. A is 5, so underneath the y stuff, we have 5 squared or 25. The co-vertices go in the x direction. B, the distance of the co-vertices is 3, so 3 squared or 9 goes under here.